Okay, this is an interesting question. We have a transmitter here and a receiver. So the transmitter transmits a microwave, which is going to go this way, and when it hits the metal sheet, it's going to reflect. So we have an incident wave and a reflected wave going in opposite directions, and when they superpose, what do we get? Standing wave, of course, like this. So there's a standing wave formed between the transmitter and the metal sheet. This receiver here actually measures the amplitude of the standing wave. So what this graph shows is the amplitude of the wave that's received at where the receiver is. So now do you realize that as the metal sheet is moved, the standing wave will move along with it, and that's why the receiver will measure a varying voltage, because the amplitude of the standing wave is being moved along as the metal sheet is being moved. Okay, let me just for example, maybe this point here corresponds to when this receiver is sitting position at the node. So that's why this here is actually a position of a node. So when it's shifted to say here, when you're at the antinode, you got a large amplitude of oscillation. So this actually tells us the position of the antinode. Alright, and then you moved further, and now the node is positioned at where the receiver is. So this is the node. And when it's moved here, don't be mistaken, the amplitude here is as large as the amplitude here, This is just showing one snapshot of an instant in time, but actually the amplitude of oscillation here is the same as the amplitude of oscillation here. So this is another antinode here. So but actually to solve this question, all you need to know is the position between two nodes or two antinodes corresponds to half a wavelength, right? So half a wavelength, if you look at the graph, this will be 60 mm. So that tells you that the wavelength is actually 120 millimeters. Okay, ta-ta!